Hello students, I welcome you all to my channel. And children, today this video is all about the multiple choice questions, objective type of questions on the chapter electricity. The purpose of making this video is to make you all familiar with the present pattern of SSLC. Hope this video will help the present 10th batch students to do well in their exam. So let me start with the first question here. Children, you can see here the question is on your screen. You can pause the video and you can try there, and you just verify whether your answer will be right or not. Let's start here. The first question: in an electrical circuit, two resistors of 2 ohm and 4 ohm are respectively connected in series to a 6-volt battery. The heat dissipated by the 4 ohm resistor in 5 seconds will be. Means you can see here there are two resistors in the circuit which are in series with a 6-volt battery, and the question is that what is the heat produced by 4 ohm resistor, okay, when for a 5 seconds of time. So you have to just first write the formula here. H is equals to I square RT. So time 5 second, that is heat produced through 4 ohm resistor. Only the current we have to find first. Okay, to find the current we can make use of Ohm's law here, that is I is equals to V by R, and here V voltage is given here, 6-volt battery. The resistance of the circuit is not given, so let's find it out first. Since both the resistors are connected in series, so we can find the resistance as a R1 plus R2, that is 2 plus 4, that is 6 ohm. So we got the R as well, so let us find out this 6 volt divided by 6 ohm of resistance, then it gives 1 ampere of current. So we got the current here. So now let us find out the heat here. There's a current is 1 here, so 1 square remain 1, resistance through 4 ohm resistor for 5 seconds. So now you get the heat developed to be 20 joules. So option B is the correct here. Yes. Now moving further to the next question here. You can see, children, here a 4 ohm resistance wire is stretched to double its length. Children, you can read the question, pause the video, yes, and try to solve it by your own. Okay, ultimately you are going to face such questions in the exam, so you have to practice by your own. Now moving to the second question here. See here, the 4 ohm resistance wire has been stretched to double its length. See here, let me just draw the wire here. Let us say there is a wire, length L, area of cross section A, and the resistance of this wire is 4 ohm. Now this wire has been stretched, it has been stretched to double its length. You need to remember, when the length is double, the area reduces to half, and the new resistance you have to find. So let me do the work here. R is equals to rho L by A, means resistance of the wire of length L and the area of cross section A is given here, it is 4 ohm according to the question. Now another wire whose resistance is 2L and the area of cross section is A by 2, and here you have to find this resistance. So now see here, R dash equals to rho 2L divided by A by 2. Yes, now you can write it as R dash is equals to rho 2L. I'll change the sign from division to multiplication. Here there will be a reciprocal of that, that is 2 by A. R dash is equals to rho L by A into 4. L by A into 4. And you can find its value is given in the question here. It's given here, it is 4 ohm. Now let us put that R dash is equals to 4 into 4, you get 16 ohm. That is option D is the correct here. Just learn what should be your approach towards such questions, children. Yes, pause and observe the things. Okay, I am going a little fast since I have more of questions to cover today in this video. So now moving on to the next question here. There's the third question is here. Work done in moving a charge of 2 coulomb across 2 points having the potential difference 12 volt. So you can first note down what has been given here. Charge, that is 2 coulomb of charge, and the voltage is 12 volt. So they have asked how much work is done on the 2 coulomb of charge, yes, in moving uh, between 2 points with a potential difference of 12 volt. Yes, work done is being asked. So we have got one equation, V is equals to W by Q. So first we will solve it for work done, which is to be found V into Q. So now voltage is already given, that is 12, and the charge, so it comes out to be 24 joules. Okay, so option C is right here, means 24 joules of work has been done by the 12 volt battery in moving 2 coulomb charges from one point to the another. Yes, now jump to the next question, read it out, try by your own. Okay, so anyhow, moving on to the next question here. Next question, it may go a little lengthy. See here, three wires we have got, three wires, copper wires having the length and the cross section area. Three wires whose length and area of cross section has been given here. The first wire of length L and the area of cross section A. Second wire whose length is 2L and the area of cross section is A by 2. And the third wire of length L by 2 and the area of cross section 2A. Among these three, which has a minimum resistance? So we'll have to find it. We'll have to solve for all those three. See here, first resistance is equals to rho L by A. See here, resist R1. Okay, resistance of first wire whose length is L and the area of cross section A, let us say it is R. Now for second wire R2 is equals to rho, length is 2L divided by, yes, area of cross section is A by 2. So now let's find out its resistance, divided by A by 2, A by 2. So further you can write R is equals to, R2 is equals to rho 2L, I'll change the sign to the multiplication here, into 2 by A. So what I get, rho L by A into 4. Here's the value of L, rho L by A, it is here, that is R, means it is 4R. Yes, it is 4R. The resistance of second wire is 4R, first is R. Now let me find out third one, whose length is L by 2 divided by area is 2A. Look here, R3 is equals to rho L by 2. I'll change the sign to multiplication. So 2A by 1 becomes 1 by 2A. Now rho L by A into 1 by 4. Am I right? 2 to the 4. Now rho L by A, its value is 4 here. So 4 into 1 by 4, it is nothing but R by 4. So R3, it is R2 and it is R1. So which wire has got the least resistance, minimum resistance? It is the wire whose area of cross section is 2A. Yes, so option C is correct here. Children, remember in what way you will approach towards such questions. Okay, that is very important. Okay, so this is how you got the, got to know that option C is correct here. Now moving on to the next question. Pause the video and try to do by your own, children. Anyhow, coming to the next question here. An electric bulb which has marked in the sense it has a rating of, the rating has been given here, 40 watt and 200 volt. It is used in a circuit of supply voltage 100 volt. Now its power. Means let me just explain you the question here first. there is a bulb with the which is having a rating of 40 watt and 200 volt, which mean when this bulb is operated on 200 volt, it will consume the power of 40 watt. If it is operated on 100 volt, then how much power it will consume? Yes, so let's find it out. P1 power 1, it's given here, that is 40 watt. Yes, V1 is also given here, that is 200 volt. P2, that is, you have to find it out. Voltage V2 is given here, that is 100 volt. Okay, so now in such cases, children, you will have to first find out the resistance. For finding on the resistance using the available data, that is P is equals to V square by R, then R is equals to V square by P. So V is here, that is 40, sorry, 200 divided by P power, it is 40. Okay, so now you got it as a, it's 200, right? So you got 1 za 5 za. In the sense, resistance is 5 ohm. It is okay. Resistance of the bulb, 1 second, square we have not taken, we'll have to take the square here. Yes, sorry for that. Okay, anyhow, see here, V is here 200 square divided by power is 40. Okay, 200 square, it is children, it is 20, is no, it is 40,000, it is divided by 40. 0 get cancelled, 4 ones means 1000. Yes, the resistance is 1000 ohm. Okay, we got the resistance of the bulb. Then now easily you can find the power when it is operated at 100 volt. Now power is equals to V square by R. Voltage now it is 100 square times R. Resistance we have got, it is 1000. 100 square, it is 10,000 divided by 1000. So here you get it as a 10 watt. So children, option C is correct here. Okay, remember how you will just do all this. Okay, remember that points how I am doing, just follow that steps. Anyhow, you read the next question here and try to do it. Okay, the next question is here. A cylindrical wire of length L and the uniform area of cross section A has a resistance R. Another conductor of length 2L and the resistance R of the same material has the cross sectional. Okay, see here the question is that there is a wire of resistance R of length L and the area of cross section A, and another wire whose resistance is also R, is same material but the length is 2L, and what will be the area of cross section X. So which option you will put here, see, so that you will get the same R you should get here. Let us try with the D option here. If I place here, that is fourth option, that is A. So what will be the answer? See here, rho 2L, sorry, L by A into 2. Yes, rho L by A's value is R here. So you get here 2R you will get, not R. So let us try with the third option, C option. R is equals to rho 2L divided by 2A. So 2 get cancelled. So what remains? R is equals to rho L by A. Rho L by A value is R. So you got the answer here, which means option C is correct here. Okay, hope you all are following the points here. Now after this, children, moving on to the next question. Next question, C. An electric kettle consumes 1 kilowatt of power electric power when operated at 220 volt. A fuse of what rating must be used for it? So let's write what is given here. Power of the kettle is given here 1 kilowatt, which is equals to 1000 watt, and the voltage on which it is operated is 220, and current rating of fuse they have asked. So using this data you can find it. P is equals to VI is, and now I is equals to P by V. So P is 1000 divided by voltage is 220. So when you divide it you will get around 4.5. Yes, 4.45 this way ampere you will get it here. Yes, means what is the close answer here? It's a D option, because you cannot use the fuse of 4 ampere, because the current of more than 5 ampere, if it flows, then it will, the fuse will blow off. That is why we have to install the fuse of 5 ampere in the circuit. So this was all about the question which, and now moving on to the next question here. The next question you can read it out here. See, the next question is here. What is the minimum resistance which can be made using 5 resistors each of 1 by 5 ohm? Hope everybody know that to obtain the minimum resistance using different number of resistor, they all should be connected in parallel. Okay, then only the minimum resistance can be obtained. To obtain the maximum resistance, they should be connected in can be series. So now let us use the parallel combination of resistors. We have got 5 here, 1 by R1 plus 1 by R2 plus so on to 1 by R5. So the value of each is given here, that is 1 divided by 1 by 5 plus 1 divided by 1 by 5, so on up to, yes, 5 times we'll take it. Now you take the LCM here. LCM, now sorry, you can write it as a 5 by 1. Yes, 5 times you can write here, 5 times. Yes, 5 times you will write here. Now 1 by Rp is equals to, LCM will be 1, add up 5 times, it will be 25. Now Rp is equals to 1 by 25 ohm. 1 by 25 means option B is correct here. Okay, due to the less space I am not writing all the times here, just try to understand. So option B is correct here. Now just see the next question. Next question, try by your own. It is same as I did this question. It is same question asked in a different way. Okay, you just read out the question and you do it by your own. Yes, same question it is, but in the different way the question has been asked. So just read the question and try by your own this question, same way. Answer will be 1 by 25 itself. Now we'll go to the next one. This question, to get the equivalent resistance of 2 ohm using 6 ohm resistor, the number of resistors required are, means how many 6 ohm resistors do you use to obtain the equivalent resistance of 2 ohm. See here, when you are going to get the minimum resistance, you should know that you are going to connect all the 6 ohm resistors in parallel. So let us start with the first option here. I'll do here 1 by Rp is equals to 1 by 6 plus 1 by 6. 2 times I'm taking. So the LCM will be 6. So 2 by 6. Then Rp is equals to 6 by 2. So I get it here 3. 3 I am getting. So it is not the option here. Correct option. So I'll try with the second option here. 1 by Rp is equals to 1 by R1 plus 1 by R2. Yes, 1 by 6 plus 1 by R3, sorry, 1 by 6 plus 1 by 6. So now LCM will remain 6, so 3 by 6. 1 by Rp is equals to 3 by 6, then Rp. Reciprocal of this, that is 6 by 3, that gives you 2. It means yes, 3 resistors each of 6 ohm can be connected in parallel to obtain the equivalent resistance of 2 ohm. So according to that, option B is correct here. Children, just follow the things here. Now moving on to the next question here. Next question. Two devices connected between 2 points. The physical quantity that remain the same between 2 points. See, between 2 points, remember, it means they are connected in parallel between 2 points. End-to-end connection is series connection. Connection between 2 points is parallel. So whenever the number of resistors or the devices are connected in parallel, the potential difference remains the same and the current get distributed. So the quantity which remains the same is the potential difference. In series, you know very well, current remains the same, potential difference get distributed. But here they are connected between 2 points, that is parallel, so potential difference remains the same. Another 2 questions we'll do here, and by this we'll wind off this class. See here, the resistance of a bulb rated 100 watt and 220 volt means you have to find the resistance of the bulb whose power is 100 watt and voltage is 220 volt. Now we have got the equation here, P is equals to V square by R. R we have to find it here, then we'll solve the equation here, that is R is equals to V square by P. V is 220 square times power is 100, so 220 square is 48400 divided by 100. So here you get the resistance of the bulb to be 484 ohm. Means option B is correct here. Yes, option B is correct, children. Here you all try there. Moving on to the last question. Yes, and we will also have few more videos on the other chapters as well. So last question from this one. 4 resistors each of 10 ohm are connected to form a square. The equivalent resistance between any two side in it. Okay, see here we have connected 4 resistors. In what way we have connected them? Such that they form a square. Okay, and we'll name the all 4 points here as A, B, C, D. Each is of 10 ohm. Yes, each resistor is of 10 ohm. Okay, then equivalent resistance between 2 points. Let us find the resistance between A and B. So now you could see 1 2 3, all these 3 are in series because they are connected between these. Okay, they end to end connected, so these are in series. Okay, so series RES is equals to R1 plus R2 plus R3, that is each of 10 ohm. So that gives out a 30 ohm, that gives out 30 ohm here. Means now I can draw the new circuit here this way. It is 10 ohm and it is 30 ohm here. Yes, now you can see these two are in parallel. So now use a parallel combination of resistor, 1 by R1 plus 1 by R2. Yes, then you can write 1 by Rp is equals to 1 by 10 plus 1 by 30. Yes, and further you can write here, that is LCM you take down, that is 30. So it is 3s are 1s are, so 4 by 30, then RP is equals to 30 by 4. Yes, you divide it children, that is 30 by 4. Yes, how much you will get children? 30 divided by 4, it is 7.5 you will get. So resistance, that is, this is right answer. Okay. And one more question we have got, last one. At the time of short circuit, the current in the circuit reduces substantially, do not change, increases heavily, varies continuously. See children, remember, during the time of short circuit, current in the circuit increases heavily. So option C is right. So these are the some questions from the chapter electricity. So even I am going to make few more videos which will involve the multiple choice questions, objective type of questions from other chapters. If you like, just if you like the video, share it and subscribe to our channel. Thank you.